Okay, welcome back. For today's video, I wanted to go over how to do derivatives of logarithms and exponential functions. So with logarithms in calculus, and especially in physics, you typically don't run into the log with a base number form. You almost always come across the natural log with base e. So we're going to work with that today. So to take the derivative of the natural log of x, dy dx, you do 1 over the stuff inside of the logarithm times the derivative of the stuff inside the logarithm. So in this case it would be x prime, and x prime is just 1, so you have 1 over x as your answer. For problem number 2, we have y of x equals ln of x squared. So the derivative of that is going to be 1 over x squared times the derivative of x squared, which is 2x. So the squared on the bottom is going to divide out the x on the top, leaving you with 2 over x. And you could also call that 2 times x to the minus 1. For problem 3, we have y of x equals 3 times ln of 1 over x. Now you can leave the 3 outside, but I'd like to show you guys how logarithms work. So we can rewrite the problem as ln of 1 over x cubed. Because remember, a number outside you can bring in, and that becomes the power of stuff inside the log. And 1 cubed is just 1, so you have 1 over x cubed inside the logarithm. And now you can use the rule of logarithms, the quotient rule, where you can split the logarithm up. So you have ln of 1 minus ln of x cubed. And now when you take the derivative of that, ln of 1 is 0, so we can ignore that. So you look with minus, and you have 1 over x cubed times the derivative of x cubed, which is 3x squared. So we have minus, the x squared is going to divide out the cubed, so you have minus 3 over x left behind. Problem 4, we have y of x equals the natural log of x over 2x plus 1 all in a square root. So we can actually rewrite this. Well, we'll use the quotient rule to split everything up. So ln of root x minus ln of root 2x plus 1. And you know that anything under square root is to the 1/2 power. So you can pull the 1/2 out. So you have 1/2 ln of x minus 1/2 is ln of 2x plus 1. And so you can take the derivative of this, which is just 1 over 2 times 1 over x, and then the derivative of x is 1 minus 1/2 times 1 over 2x plus 1, and then the derivative of 2x plus 1 is just 2, because the 1 goes to 0. So we just simplify, we have 1 over 2x minus 1/2 times 2 is 1, so those divide out. So you're just left with 1 over 2x plus 1. And I don't feel like simplifying that, so we can stop there. I'm going to move on to exponential functions now. So for number 5, we have y of x equals e to the x. And to take the derivative of an exponential is actually somewhat straightforward. It's just going to be e to the x times the derivative of whatever's in your exponent. So in this case, it's x, so we do x prime. And the derivative of x is just 1, so this is just going to be e to the x. So for 6, let's see how this works when we start adding a bunch of stuff to exponents. So we're going to have 3 times e to the 4x, and we take the derivative of that. I'm just gonna rewrite the problem for the term, and then take the derivative of the exponent, which is going to be 4. So I'm going to simplify that. You have 12 e to the 4x is your answer. Problem 7, you got y of x equals 2 over e to the x minus the square root of 2 times e to the 10x. So we can just rewrite these terms so they're easier to take the derivative of. So 2 times e to the minus x, and then we're going to minus root 2, and then the square root of e to the 10x is the same as e to the 10x to the 1/2 power. So when you rewrite that, it is just e to the 5x. And now we can take the derivative. So 2e to the minus x is just going to be minus 1 times 2 e to the minus x. And then we have minus root 2. And the derivative of e to the 5x is just 5 times e to the 5x. And write that. And we're left with minus 2 over e to the x minus 5 root 2 times e to the 5x. I'm going to make this the last problem. So we have y of x equals e to the ln of 4x minus ln of x squared plus e to the root 5 times x. So we can rewrite the original statement. The exponential gets rid of the natural log. So we're just left with 4x. And then these other two terms are the same. So we can take first derivative. Should have mentioned over here, we're looking for the second derivative of the term. So the first derivative of 4x is 4, and then for x squared you have 1 over x squared. The derivative of x squared is 2x, and then we have root 5 times e to the root 5x, and then we take the second derivative. 4 goes away because it's a constant, so let's write 0. And then should rewrite this because you have 2x over x squared. The x is going to eliminate the squared, so you just have 2 over x, or 2 times x to the minus 1. So the derivative of that minus, you have minus 1 times 2 times x to the minus 2. And then we take the derivative of this term again with exponential. You have root 5 squared, which is just 5, and it's still times e to the root 5 of x. So when you rewrite this, you have 2 over x squared plus 5 times e to the root 5x. Class dismissed.